Looking at hormones, most of them are peptide hormones. So this is bringing you back way to the beginning of AMP1. So peptides, remember, are going to be kind of a chain of amino acids. So you have amino acid chain. Um, and before it gets to a protein, you have to have kind of 1,000 amino acids um, chained together, or 100. So peptide is just a smaller amount of amino acids chained together. So they can be short polypeptide chains. They can also be smaller proteins. So we can get to the point where there's enough amino acids in the chain to be a protein. We also can have glycoproteins. So those are going to have proteins with sugar attached to them. So you can have a protein with a carbohydrate signature on the surface. That can be a hormone as well. Polypeptides, kind of with the carbohydrate side chain, so these glycoproteins, examples are going to be things coming from the pituitary gland, which is these three. This is thyroid stimulating hormone. This is luteinizing hormone, and FSH is follicular stimulating hormone. Both of these are going to be for reproductive purposes. So again, we'll touch on these here, but we're going to go into these a lot more significantly when we get to the reproductive system. Thyroid stimulating hormone we'll talk about coming up. We have lipid hormones. So these are going to be made of fats or triglycerides. So we have carbon rings where they can be fats in rings and kind of like that. And then they can have side chains, so they can have things coming off of it. Not going to go into the kind of organic chemistry of it all. They can either be from fatty acids or cholesterol. Usually the cholesterol is going to be the rings. Fatty acids can be those chains that come off. And they can be eicosanoids. So these guys are fatty acids. I'm going to talk about paracrine factors coming up in a slide in a minute. So paracrine factors that can help kind of organize cellular activity and make sure enzymes in the extracellular fluid are working right. So we have hormones that we think about that are going to go all over the body, but we also have paracrine hormones, or even autocrine, which are going to affect neighbors. So I'm going to go into more detail of this coming up. So these are going to be smaller hormones, lesser known hormones than we're necessarily going to talk about in this section. But this is going to be ones that a cell makes it and affects its neighbors. So you can coordinate all the cells in an area and the enzymes in the extracellular fluid. So you can kind of organize an area to do what you want of whatever activity. Steroid hormones are going to be lipid based. These guys, because they're lipid soluble, to circulate in the bloodstream, remember plasma is a lot of water. So lipid and waters do not mix. So how do you get these fat-based hormones to move around, especially steroid-based ones? Well, they have to have a carrier or a transport protein. So what happens is they are usually steroids or rings, and they have a protein that'll attach to them, and this will make them mostly water soluble, and so then it can transport it throughout the blood. These guys, since they have transport proteins, they can stay in the bloodstream a little longer because they're just hanging out with their transport protein. So transport proteins here. So they can hang on for a little longer before they need to move on. So they're not dissolving out of the blood, or diffusing, I should say, out of the blood, because they're just hanging out with their buddy, the transport protein. Some examples of these steroid hormones are going to be androgens in males. So this is going to be testosterone mainly. And then estrogen and progesterone in females. Corticosteroids, so it's kind of in their name of steroid hormone. Corticosteroids are going to be released by a specific area in the adrenal gland. And calcitriol, remember, this is the active hormone from vitamin D. So remember, vitamin D goes to kind of the liver as an intermediate form, and then goes to the kidneys and is made into calcitriol. And then calcitriol allows all the absorption of calcium, in your intestinal tract. Again, I mentioned this before, hormones so you have to have a relationship between the hormone and the receptors on the target tissue. So you can have a bunch of the hormone being released, you can have a bunch of hormone kind of in the bloodstream, but if you don't have the appropriate receptors on these cells, then they cannot have their effect. So need both. You need a hormone plus the receptor to get both of them. If you don't have hormone, you're not having the proper function. If you don't have the receptor on the cell, then you can't have proper function. And what we can do with receptors on our target cells, they can actually be made and removed depending on what's going on in the body. So when we talk about down regulation and up regulation, it has to do with the receptors. We're not talking about kind of differing because is a response because of the level of hormones. But when we say up regulation, it has nothing to do with the hormone, at least in the kind of the way you think. Down regulation, it's having to do with the receptors. So up regulation is going to be an increase. So upreg is increase in receptors. Well, why do you think we would want to increase the amount of receptors that we have on the surface of our cells? So you want to go from having 2 receptors to having 6. This is in response because your levels of hormone are low. So you have low levels of hormone. Why would you want more receptors? Well, if you only have kind of 3 molecules of the hormone and you really want this hormone to come in, well, there's more of a chance for the hormone to meet its receptor if you have double the amount of receptors than you have hormones. So there's more likelihood that this hormone is going to meet its receptor on the target cells if there's just a lot of them. So this is going to be in response to low hormone. You're going to try to make the hormone as effective as possible because there's more opportunity for it to match with its receptor on the target cell. So then we have down regulation. So down regulation is the opposite. This is going to decrease the amount of receptors. This is in response to a high amount of hormone. So what happens is if you have, say, your same example, you have kind of 6 hormone molecules, and then you have 6 receptors on your cell, well, this is going to mean that each kind of hormone molecule can go on a receptor and you can keep having this effect. So the hormone keeps going and keeps having this effect on this target cell. Well, the target cell is tired. It doesn't want to have the effect of that hormone anymore. So how can it decrease the effect? Well, it can decrease the amount of receptors. So you still have 6 hormone molecules, but if you only have 3 receptors, well, only 3 of your hormone molecules can attach to these receptors at a time. So you have less of an effect. You don't have as many hormone molecules going to this target. So they'll move on and go someplace else, and there's only a certain amount of receptors. And again, to have its effect, it has to have a receptor. So no receptor, the hormone's just hanging out in your bloodstream. Doesn't have the effect on the targets. So upregulation is increase the amount of receptors because of low hormone levels. Downregulation is decrease the amount of receptors. So when we're saying up or down, it's the number of receptors. And it's the opposite for the hormones. So downregulate with high hormone levels. The hormones, again, are chemical messengers of the endocrine system. So they're going to be long distance, meaning that they can go from your pituitary gland all the way down to your adrenal glands and even lower your intestinal tract, all of those things. So it can go from all long distances from your head to your toes throughout the bloodstream and can travel in the lymph too. So if it gets outside of the capillaries, it can travel in the lymph. There are two different kind of kinds. So we're talking about again hormones, but these are going to be more locally active hormones. So these don't go long distances. They're just a little bit different. Autocrines, when we have auto, it means self. And so these are self hormones. They're chemicals, just like hormones are chemical messengers. So they're a chemical messenger that are made by the cell and have the same effect on the cell. So you can see in this picture here, this is an autocrine. The cell is secreting or exocytosing these hormones, and then literally the hormones are going around to the outside to go to their receptors to have the effect on the same cell. So you can kind of think of it as leaving yourself a note. So you write it down and then you can remember it and have the effect on yourself. Paracrines are still locally active, where they're made by a cell and they go to nearby cells. So they're not going into the bloodstream like a typical hormone or the lymphatic system. They're just being produced by a neighboring cell and travel through the extracellular fluid to a nearby cell. So this is going to be locally acting. So say your stomach makes paracrine. So your cell is gonna make something, and then it's gonna travel to nearby stomach cells and have its effect. So nothing to do with the bloodstream when you're talking about autocrines and paracrines.